In this video, we're going to talk about structures and functions and passing structures into functions and getting data back out of the function and back into the structure. When a structure is passed into a function, and remember that a structure is a combination, an assembly of different variable types. When a structure is passed into a function, all of the members of the structure have to be copied. That's a pass by value. And that's just the way that any other variable is passed as well, passed by value, until we get into pointers, and then we can pass by reference. So we can pass the address of a variable and work on that actual address in memory. A function then has to return the whole structure to affect the original structure that we wanted to cause some work to be done on. Now that's a lot of copying of variable values onto and off of the stack. It's called pushing and popping. And it's very inefficient, and it takes a lot of time for the microprocessor to do that sort of work. A lot of time is microseconds, but still, it's time that we could better use doing something else. Pointers will be used later on to make this better. We have a video coming up in a few where we talk about pointers to structures, but for right now, we're not going to go that way. I want to show you actually passing small structures back and forth to functions. And imagine if you could store a function in a structure, and then that function would only work on the members that are in that structure. You're getting ready for object-oriented programming. Here is a little thing I called structs2. I pick up my standard IO and standard lib, and here I have a structure called date. This is the declaration of the structure. It does not set aside any memory. It just says that date is a new type, and it will have an integer month, day, and year in it. Pretty slick, huh? And we have a declaration of a function called addDecade. It will take in as an input a date structure, one of these things. So there will be 3 integers really going into here, into this function, and it returns nothing. It's a void. So nothing will be allowed to come out of addDecade. Here we'll run the program and start our main. Here's our birthday structure, bday, and it is a struct date. So it's this type, birthday. We got a little character buffer to take in data, and I ask you 3 intelligent questions here. I say, what month were you born? And I do an ASCII to integer of a getString secure, pass the buffer, and a max bytes of 50. So this is going to read a string from the keyboard up to 50 bytes long, stored in the buffer, and then return a pointer to buffer to the ASCII to integer, which takes the string of characters that you type in and turns it into a number. And then the number will be stored in the month, bday.month. Remember our dot? That's our member access, so that we can get to month. And day and year. We do it 3 times, and then I print out you were born on this date, bday.month, day, and year, and then we're going to add a decade to the birthday. So we pass the birthday down to addDecade, and then it'll do its job, and we'll print out you'll be 10 years older on, and we print the new date. addDecade does not return anything, just as we set up at the top. It takes in a structure, date, and I call it target because it doesn't really matter. We just need a name for it. And we say that the target year plus equals 10. We add 10 to the target year, and then we go back up here. So that's structs2, and let's see what happens when we run that. Here we'll bring this up. We'll compile and link it. Structs2, and what do you know? It works. It compiles anyway. So structs2. We'll run it. What month? That was July. Enter. And that was the 20th. And I'm a really old guy. And you were born on this date. You'll be 10 years older on. Uh-oh. Looks like an error. 72060. It didn't add 10. It didn't do what it was supposed to do. So we've got a logic error. Our syntax is great, but somehow, logically, we're not doing what we wanted to do. Well, let's open another file that I already have here so you don't have to watch me type. Pick up structs3.c. Here everything is the same, but now look at addDecade. We changed it up on you here. Look at that, structs3. We have addDecade, and now it's going to be allowed to return a structure date. Remember, we had this as a void before where we said it couldn't say anything back, couldn't return anything. Well, now it's going to take in a date, and it's allowed to return a date. And down here, we'll say we'll get our questions answered, and then we'll say that the birthday equals the results of add decade of birthday. Now we'll pass the structure date target into our function, do some work on it, and then return it back to here. So all the values have to be copied down here. Now imagine if that's a big structure, a database record or something like that. That's a lot of data to put on the stack. And in some runs of the program, maybe that's too much data to put on the stack, and it would be terribly slow. So here's our new function declaration down here, or definition, struct date. We say that add decade will return a date, and there we do the math again on the target year, and this time we return the target. We send it back. So that's struct 3. Let's see if there's any difference. Compile and link it. There we go. Struct 3. All of our inputs. That's a little better. You'll be 10 years older on 7/20/70. And of course that should probably say you'll be 10 years old, since I asked for when you were born and we added a decade to it. So we probably have some logic about some other structures. Hang in there. See you in the next video.